In this video, we're going to learn how to find the derivative of a function. So what is a derivative? A derivative is essentially a new function that describes the instantaneous rate of change of an old function. For example, you might be given a function of f of x, and they want you to calculate the derivative of f of x, which is often written as f prime of x, is equal to what? Or you can also have a function in terms of y. Then they can ask you what is the derivative of y, which can be written as y prime or dy dx. They essentially mean the same thing. So what is the derivative of y respect to x? So these are the questions you might encounter in the derivative section. The good news is we're going to have some rules to help us calculate the derivative. And once you know how to use them, they become pretty straightforward. Let me give you a quick overview about the rules. The first rule we're going to learn is called the power rule. You can use power rule whenever you see an x to the nth power. This rule only includes very simple manipulation of a function. So for the difficulty level, we're gonna give it a 2 star. The next rule we're going to learn is called the product rule. You're going to need product rule whenever you have a function times another function. For this rule, we'll give it a difficulty level of 3 stars because the equation is slightly longer than the first one. The third rule we're going to learn is called the quotient rule. So here we're just trying to get you familiar with the name of the rule. And for this rule, it's also pretty straightforward to use as the product rule. It can be a little bit long, but it's not going to be too difficult. So we'll give it a 3 star for this rule. And the last rule we'll learn is called the chain rule. This one is a bit tricky because we're trying to take the derivative of a function that is inside another function. So essentially you have an inside function g of x and you have an outside function f of x. So this rule, you not only need to know how to use the rule, but you also need to know when to use this chain rule. So for the difficulty level, we'll give it a 4 star. So let's look at these rules one by one, and hopefully by the time of the chain rule, it will all make sense to you how to calculate the derivative. First, let's look at the power rule. Okay, in here we have a function y equal to this polynomial here, and we want to find y prime, which is the derivative of y. And this is a perfect question to use the power rule. Let's look at the term one by one. For the first term x to the fifth power, based on the power rule, we need to bring the 5 down in front of x as a coefficient. So 5x to the, for the power term, we need to minus 1 or reduce the power by 1. So we have 5x to the fourth power as stated here, x to the nth power. All we gotta do is move the n in front of x. And for our power term, we have n minus 1. So our x to the fifth power becomes 5 times x to the fourth power. Okay, then we do the same for the next term. If you see this is 3x to the fourth power, the 3 is a coefficient, so we can keep the coefficient in front of our term, which it becomes 3 times 4 because we bring down the power, x to the 4 minus 1 power, which is x to the third power. You can also rewrite this term as 12x to the third power. 12x to the third power. Okay. So we've done the power rule for the second term. The third term, we have 6 times x. We can use this equation here, which states that whenever you have a constant times x, the derivative of that will be the constant. So for example, the derivative of 5x will just be 5. So in this case here, the derivative of 6 times x is going to be 6. So we calculate the derivative for that term. And last but not least, we have a constant. And our last rule, which is very convenient, states that the derivative of any constant is equal to 0. So if you have any constant number, large or small, as long as there is no variable x in it, you're gonna have a derivative of 0, which you don't have to write it, but let me just say it here. We have a 0, which is the derivative of 2. And now you've done the calculation. The derivative of y is going to be 5x to the fourth power plus 12x to the third power plus 6. And this is how you use a power rule. Let me give you another example. Y is equal to x to the fourth power minus 3x to the second power plus 51. Can you try that on your own? And I will quickly write the answer here. So y prime will be equal to 4x to the third power minus 6x and plus 51. That will give us 0. So our y prime will be equal to 4x to the third power minus 6x. Let's look at the product rule. We will use product rule when we have two functions multiply each other. To calculate the derivative of that, first we would write down the derivative of the first function times the second function plus the first function on its own times the derivative of the second function. Let's look at an example. Here we have y equals these two functions times each other. Of course, one way to do it is you can open the parentheses times each term out and then take derivative of each term by using the power rule. However, if your function become more complicated, that soon becomes very time consuming. Therefore, let's try the product rule. The derivative of y is going to be the derivative of first part, which give us 2x plus 2 times the second half of the function, 3x plus 5, plus the first part on its own times the derivative of the second function, which is just 3. Okay, now basically we already got the answer. We can further simplify this expression. Here, you have done calculating the derivative of this function. And here we have our quotient rule. In general, we want to use quotient rule when we have a function divided by another function, and we want to calculate the derivative of that. And here's the general equation you want to use. It looks a little long, but all it is, it's saying if you have a function on top of another function, which is, we call the top one the top, the bottom function the bottom. On your denominator, you're gonna have the bottom function to the square, and on the top, you're gonna have the top function taking the derivative of that first times the bottom function minus, watch out for the sign here, this is a minus sign, which means the order of which one to take the derivative first cannot be switched. To minus the top function times the derivative of the bottom function. Let's look at an example. Let's say we want to find the derivative of this function. We first will have, on the denominator, we have the square of the bottom function, so 4x plus 1 squared. On the top, we have the derivative of the top function first, which is 2x, times the bottom function, which is 4x plus 1. Then we want to minus the top function. We write down as is, x squared plus 2 times the derivative of the bottom function, which is 4. Now we already got our answer. Let's simplify it a little bit further. The bottom, we can keep the parentheses as is. 4x plus 1 squared. On top, we have 8x squared plus 2x minus 4x squared minus 8. And we have the bottom, we keep the same. The top, we simplify the terms to 4x squared plus 2x minus 8. So here you got your answer. So overall, the quotient rule is a bit long. Two things to notice. One is the sign is a minus sign. One is the order of who take derivative first. Always remember, you want to take the derivative of the top portion first. Last but not least, we have the chain rule. So let's look at when do we need to use the chain rule. We need to use the chain rule when we have a composite function, which in other words, we have a function inside of another function. So this expression here, our h of x is the inside function. Our g of h of x, so our function g, is the outside function. The rule is stating that we want to take the derivative of the outside function times the derivative of inside function. Let's look at our example. So we have f of x is equal to 3x plus 2 to the 7th power. In this case, our inside function is 3x plus 2. So let's say our h of x is equal to 3x plus 2. Our outside function, g of x, is going to be h of x to the 7th power. That is our outside function. Once you get used to the inside-outside function, you don't have to write specifically this way. This is to help you to understand how to use the rule. So if we want to calculate the derivative of f of x, let's first find out the derivative of outside function, which we use the power rule. We have 7 times h of x to the 6th power. Then we need to times by the derivative of inside function, which is just 3. So now let's plug in our h of x, which is 7 times 3x plus 2 to the 6th power times 3. We can combine the constant, we get 21 times 3x plus 2 to the 6th power. And that is the answer for this question. Okay, let's try a slightly different example. Okay, the derivative of that will be, first, we want to do the derivative of the outside function, which we bring the 4 down. We keep what's inside the parentheses the same, 4 times 3x squared plus 2x minus 5 to the 3rd power. So we use the power rule for the outer function. Now let's calculate the derivative of the inner function, which we times the derivative of that is 6x plus 2. Okay, so now you're done. We don't have to simplify this function further, so this is already your answer.